Okay, so consecutive integers, we have to kind of understand what a consecutive integer is. So consecutive integers are, well, you know, you have 1, 2, 3, so on, right? How far are these away from each other?
1.
1. So these are 1 away. So consecutive integers are 1 away from each other. But what about consecutive odd?
They're 2 away.
Yeah. It'd be like 1, 3, 5, and so on. Or consecutive even.
2, 4, 6.
Again, 2, 4, 6. So they're 2 away also. Okay, so those are the 3 concepts that they're always going to toss at you. This one's a fun one because it's the product of 3 consecutive integers. And so when we think of 3 consecutive integers, we want to think of one of them being x. And then the next one would be
X plus 1.
x plus 1. And then the third one would be
X plus 2.
x plus 2. Because you're just, you know, going up. So now we have our 3, and there they are. Done. My first and last, no, okay. So, but they're 6 times the first. So the product of these, that means that
It equals 6x.
I'm doing the product of these 3.
Oh, okay.
So I'm saying x times x plus 1 times x plus 2 is equal to 6 times the first. Or 6 times this first one is 6x. So that's the whole key here. This is just the are or the is, whatever it is. Okay? And then the product, so that's these guys being multiplied. Let's do that in green. Okay? And then 6 times the first, just remembering the first guy. And so now we have an equation and we can just solve it. But we got to manipulate it a little bit, right? So let's just do these guys first. Clamshell it. X squared 2x plus x plus 2. And then times x is equal to 6x. And again, clamshell it, or in this case, everybody on the block gets the paper distribution. So x cubed, x 2x squared plus x squared plus 2x. Okay? And then I can equal 6x, and so now I'm going to move that 6x over. And I could also collect these like terms, right? So all at the same time, because we're big boys and girls now in 102, and we can do 2 things at once. So what I'm doing is collecting these like terms. Let's do that in green. Collecting these like terms by just adding them up. So I got x cubed plus 2x, or actually 3, sorry, 1 and 2 is 3, x squared. And then negative 6x plus 2x is minus 4x. Right? And so now I can begin to work the problem. So let's work the problem over here. I've got x cubed plus 3x x squared minus 4x equals 0. And now I can just factor out
Get your x.
the x, and I'm left with
X squared plus 3x minus 4 is equal to 0.
okay. So now I can write this down as x times x squared plus 3x minus 4 equals 0, right? And then bring down your factor. Your GCF is just your GCF. But now we're going to factor this out. So I have an x, and this sign comes down. This tells me that they are different. These two signs are different. Okay, and then I've got my product and my sum. My product is first times last, which is 4. My sum is 3. I'm subtracting in the sum. So two things that multiply to be 4, subtract to be 3. 4 and 1. 4 and 1. Okay, there's no star variable, so I don't have to take anything out. I'm there. Now I have my 3 factors that equal 0. So if any one of these equals 0, it's going to make the whole thing equal 0, right? So I get to solve for this factor equal to 0, for this factor equal to 0, or for this factor equal to 0. And when I do that, I get x is either 0 or minus 4, and I get x is equal to minus 4. And then I also get x is equal to 1. So plus 1, and x is equal to 1. So if that's true, I have some things going on here. I don't think 0 is going to work for me, right? Although 0, 1, 2, right? It would work. 0, 1, 2, and then what's 6 times 0? 0. So it works. So the first number could be 0, and then the second number would be, right? The first number could be negative 4. And then the next number would be and negative 2. Okay? And so let's see if that works. 4 times 3 times 2.
24.
24. And negative, right? And then what is 6 times negative 4?
Negative 24.
Perfect.
So how would you write it? Would you write, I mean, because there's so many possibilities.
Well, in this case, it's asking for what's the last integer. And so the last integer could be negative 2, 2, or one more, right? What if it was 1? 1 and 2 and 3. We always want to double check what's 1 times 2 times 3.
6.
And what's 6 times 1?
6.
So it works. So the last integer could be negative 2, 2, or 3. And that's how you would write it. The last integer could be negative 2, 2, or 3.